In the previous lecture, we discussed the topic hybridization and we explained Sp3 hybridization. Is it clear? In previous topic, we discussed Sp3 hybridization. You can watch this lecture in description of this lecture. Today we discuss the topic Sp2 hybridization. First, again, we discuss hybridization definition first. Two or more atomic orbitals having same or nearly same energy intermixing to form new orbitals that have exactly same energy and bond length. This is the definition of hybridization. These orbitals are called hybrid orbitals and this phenomenon is known as hybridization. So today we discuss the topic hybridization, Sp2 hybridization. Sp2 hybridization. The definition of Sp2 hybridization I will explain after the concept of this topic. VBT explain the structure of BF3. BF3 is boron trifluoride. Boron trifluoride. The ground state electronic configuration of boron is, because 5 atomic number, 1s2, 2s2 and 2p1. This is the ground state electronic configuration of boron. Is it clear? This is the ground state electronic configuration of boron and this is excited state. This paired electron jump from here to p second orbitals. Is it clear? This is the valence electrons. So VBT explain the valence electrons that are unpaired. So this paired electron jump from here to p orbitals and this is the excited state for boron. Is it clear? This orbital is s and this orbital is p and this is p. Is it clear, student? So this is the excited state of boron. Now we discuss the ground state electronic configuration of fluorine is F is these are the valence electrons F. So BF3, in BF3 there are 3 fluorine atom. So F ground state this and second F is this and last F is same like this. Is it clear? These are the electronic configuration of fluorine ion in BF3. The F3 to p orbitals have the outermost electrons are unpaired. It's follow the VBT valence bond theory and these orbitals intermix with these unpaired electrons. If these p orbitals make bond with this s, then bond is sp. If these p orbitals make bond this p, then the bond will be pp. And this bond, unpaired bond with this p orbital, so the bond is pp. From here we can conclude that this is sp bond, this is pp bond and this is pp bond. It is not possible in BF3 according to hybridization concept, because in hybridization we also discussed that the intermixing orbitals having the exactly same energy and bond length. Here these are the bonds are different, so their energy and bond lengths also different. In this case, these orbitals of excited state of boron intermix each other to make hybrid orbitals. there are 3 orbitals, one is s and 2s are p orbitals. These 1s and 2p orbitals intermix to form 3 sp2 orbitals because 1s and 2p orbitals intermix. So the after excitation the hybrid orbitals intermix. This is the s orbitals, sorry, unpaired. This is s orbitals and this is p orbitals of boron. These are the unpaired orbitals s and p. These 1s and 2p orbitals intermix to form 3 orbitals having the same energy and bond length. These are sp2 orbitals, sp2 orbitals and sp2 orbitals. Now from 3 fluoride ion, the unpaired electrons from each fluoride, here you can see that each fluorine has unpaired valence electron. This unpaired electron, valence electron, this unpaired valence electron, this unpaired valence electrons intermix and bond, making a bond with this boron unpaired electron. So this is the bond between one fluoride electron, sorry, spin will be changed, and this will be the third fluorine ion. So this is the bond between sp2s, sp2s, sp2s. Here we can conclude that we can see that the bond will be ssp2, ssp2 and ssp2. These bonds are the same and having the same bond length and energy. So the hybridization concept from BF3 is cleared from this example of BF3. So BF3 followed Sp2 hybridization. This is the example of Sp2 hybridization, boron trifluoride. Now we explain the geometry and angle between boron trifluoride. In BF3, this is the bond between BF3. This is fluorine and this is also fluorine, this is also fluorine. The angle between each bond is 120 degree. This is the structure of BF3. Is it clear? Now we will draw the geometry of BF3. This is the geometry of BF3. This is p orbitals and this is also a p orbitals and this one is also a p orbitals. Here you can also see that this is small lobe. This small lobe is s orbitals of BF3. Is it clear? And the bond angle between each orbital is, each bond is 120 degree. So this geometry of boron is called triangular pyramidal. Triangular pyramidal because each bond make a pyramidal of each like this. Is it clear? That's why this geometry is called triangular pyramidal. The angle between each bond is 120 degree. So every molecule having sp2 hybridization having triangular pyramidal geometry and angle between each molecule, each bond is 120 degree. So these are the concept of sp2 hybridization. If you have any question, you can ask in comment section.